We're going to take a look at the rules to exponents, and these are just a few of the rules. These are not every single rule to exponents, but just a few of them. We're going to do that taking a look at a PowerPoint slide that I used in class for notes. This slide is going to introduce the rules by first showing examples to let you see how it actually works, and then giving the rule at the very end. So if you don't quite understand, you may have to go back and watch this a couple of times to completely try to understand the rule. We're going to look at 4 of these rules. The first rule, or the first example for the first rule, is 2 to the third, x to the fourth, y squared. Now, this works out. 2 to the third is 2 times 2 times 2. X to the fourth is x times x times x times x, and y squared is y times y. Now, just a quick thing on the fact that this 3 right here, the 4 and the 2, these are called exponents. And then the exponent is always attached to a base. And so in this case, 2 is a base, x is a base, and y is a base. The exponents tell us to multiply the base by itself this many times. So 2 was multiplied by itself 3 times. X was multiplied by itself 4 times, and y by itself 2 times. And the result was this right here. The next problem is 3x to the third, y to the fourth. Now, a lot of people will say that this 3 right here goes with this 3 as well. But if you take a look, it does not. This 3 is no longer a base. It's a coefficient. And so we just put that 3 out in front, and then this is x to the third, so x times x times x, and y to the fourth, y times y times y times y. The next example is 7x y to the third. Once again, a lot of people think that this 3 would go with the x or maybe even the 7, but it does not. You can see here that we have 7, just 1x. There is an understood 1 exponent right here. So there's 1x, and then y to the third. Now the rule that this is going to create is exponents go with the base to the left, and only the base directly to the left. So you can see right here, this 3 went with the base y, and only y. It did not go with x or the 7. So that's the first rule, is that the exponent goes only with the base to the left. This 3 only goes with the x. So, and it does not go with anything else. For the second rule, we're going to start off looking at negative 3 squared. A lot of people will think that this means negative 3 times negative 3, but as we take a look, you can see that the negative simply stays to the outside, and this is really 3 times 3, giving us an answer of negative 9. Once again, this is something that is commonly mistaken. A lot of people want to put this down as negative 3 times negative 3 and make it a positive 9, but it is not. The next example, we have parentheses around this, but you know, a lot of people want to say that this is negative 4 times negative 4 times negative 4, but even though these parentheses are around it, this is really still just negative 4 to the third power with this negative sign staying on the outside, and then 4 times 4 times 4, giving us an answer of negative 64. Now, had this 3 been on the outside, the answer still would have been negative 64. This is why I wrote this out right here with the negative on the outside, and then 4 times 4 times 4. In this case right here, with the exponent on the inside of the parentheses, the negative still is not included with the base. This really kind of goes with the first rule, saying that the exponent goes with whatever is to the left and only with what is directly to the left. This negative sign is not included with the base. Now when we take a look at this one, because the parentheses are around the negative 2 and the exponent's on the outside, now the base is what's to the left, and the parentheses mean that our base is actually negative 2. So in this case, it's negative 2 times negative 2 times negative 2, which would give us a negative 8. The next one, Once again, the exponent's on the outside of the parentheses. So the negative is included with the base, and this would be negative 3 times negative 3 times negative 3 times negative 3, giving us a positive 81. Now, something that I want you to notice is that even when the negative was with the base on this one, it was still a negative answer. Well, the reason for that was the exponent was odd. Whenever we have an odd number of exponents, our answer will always be negative. And the reason for that is two negatives make a positive. So if these two negatives make a positive, the fact that we have an odd number, this turns it right back to a negative. Well, down here, whenever we have an even exponent, then two negatives make a positive, two negatives make a positive, and my answer stays positive. So anytime we have an even number of exponents, it's going to be positive, and odd would be negative. So the rule that's made by this is negatives are not included with the base unless there are parentheses around the negative and the base with the exponent outside of the parentheses. Then the second part to this is when there are parentheses around the negative and the base, odd exponents have negative answers and even exponents have positive answers. Now going back up to the first part of this rule is that the exponent has to be outside of the parentheses. Notice right here with the exponent inside of the parentheses, it still did not make this negative go with the base. The exponent has to be on the outside of the parentheses for the negative to be included with the base. And then once again, that last part, just reiterating that if we have an odd exponents, that it'll be a negative answer, and even is going to be a positive answer when the parentheses are around the negative and the base. So once again, the parentheses have to be around the negative and the base, and the exponents have to be on the outside for this to happen. The third rule, this is a pretty simple rule. It doesn't always make a lot of sense, but the rule itself is pretty simple. 3 to the 0 is equal to 1. Right now, when you look at that, it just doesn't make a lot of sense because probably the answer of 3 would make sense. Even the answer of 0 would make sense, but 1 just doesn't make sense, and I will explain that here in just a second. Looking again, x to the 0 is also 1. Now, this one, a lot of people start off saying this is 1, but if you remember that last rule, there's no parentheses right here, so the negative is not included with the base. So the answer to this one is actually negative 1. Okay, in this case, the parentheses are around the negative and the base, so this one would be just 1. Now, the rule here is any base to the 0 power is equal to 1. Now, like I said, it doesn't always make sense why. So what we want to do real quick is try to explain why this is. So the best way to explain this is to take a look at some of the previous exponents, 2 to the third, 2 to the second, 2 to the first, and then we can take a look at 2 to the 0. Notice each time we subtract 1 as we go down, and every time that we subtract 1, we divide by 2. So we were at 2 to the third, and when we subtract 1 and go to 2 to the second, we divide by 2 and we get an answer of 4. We subtract 1 again, and we divide by 2 to get an answer of 2. Well, when we subtract 1 right here, when I divide by 2, 2 divided by 2 is going to be equal to 1. Well, every single number is set up this way. So over here, when we have 3 to the 0 power, 3 to the first power was 3. So when we do 3 divided by 3 to get 3 to the 0, we get an answer of 1. So the explanation isn't always popular. Kids are always expecting something great, but that is the reason why 3 to the 0 is 1. Okay, looking at the fourth rule, and down at the bottom, it does say that all final answers must be positive. That actually should say that all final answers, exponents, must be positive. And so if you'll take a look here, we've got a negative exponent. And so we've got to make this positive somehow. And you see that we have an answer of 1 over 5. Well, to begin with, this doesn't make just a tremendous amount of sense because we probably weren't expecting to get a fraction. So let's go ahead and move on to the next one. We have x to the negative 5, and we need to make this positive. And we get 1 over x to the 5th. So maybe some stuff starting to make a little bit more sense now, but let's keep going. So we do this one. Now this one is a fraction, and the negative exponent's on the bottom. And so let's take a look and see what happens here. This one, all of a sudden, it's no longer a fraction, and we get x to the 7th. So let's go back and look at these three. This one started off as 5 to the negative 1. And then when it became positive, it was 1 over, this was 1 over 5 to the first power. So this right here got flipped to the bottom of a fraction and became to the first power. This right here was x to the negative 5, and it got flipped onto the bottom and became positive as well. Now, some people are saying, well, where'd the fraction bar come from? Well, anytime you have a whole number, it's always understood to be over 1. So that whenever you take this and you flip it to the bottom, this 5 to the negative 1 becomes 5 to the positive 1, the one's understood here. And because there's nothing left on top, we go ahead and put a 1. So once again, there was a fraction bar understood to be right here. It flips to the bottom, and because there's nothing left on the bottom, or I'm sorry, on the top, we just put a 1 there. Now this one was already a fraction. So when we got our negative 7, this one flipped up to the top. And when it flipped up to the top, there was no need for a fraction bar anymore, so this one just became x to the 7th. Let's take a look at a little bit bigger problem, and maybe this will start to make a little bit more sense. If we take this right here, once again, this is one big fraction bar. And so if I was to take my negative exponents, the a to the negative 2 and c to the negative 5, I could flip them down to the bottom and make them positive. This would leave me with 4 on top, because it's positive, it stays. B to the 3rd on top, it's positive, it stays. But these two right here flip to the bottom. The next example is a huge example. And so, once again, we still have a fraction. And what I want you to see here is that every one that has a negative is going to flip. So 9 to the negative 3rd was on the top. It flipped down to the bottom and became positive. Now a squared was positive, so it stayed on top. B to the negative 4 was negative, went down to the bottom and became positive. C to the negative 2 was negative, went down to the bottom and became positive. Oops, sorry, didn't mean to click that. But just as we continue on here, 5 to the negative 2 was negative. Now this one flipped to the top. So if it's not that all negatives go to the bottom. If it's on the bottom and it's negative, then it flips up to the top. And then x to the negative 7 will flip up to the top, but y to the 3rd is positive. It's going to stay on the bottom. So if it's positive, it stays where it's at. Only the negatives flip. And if the negative is on the top, it flips to the bottom. If it's on the bottom, it flips to the top. So going to the rule that I've already clicked, when a base has a negative exponent, the base and the exponent will flip the top to the bottom or the bottom to the top. When it does, the exponent will become positive. So in every single one of these, the exponent flipped to become positive. And like we said, if it was already on the bottom, then it flipped up to the top and became positive. Right here is a really good example of putting the entire rule together. And like I said, negative on the top, flip to the bottom. Negative on the bottom, flip to the top. But if it's positive, it must stay. So a squared was positive, stays on top. Y to the 3rd is positive and stays on the bottom. So this right here is just 4 of the rules with exponents. Like I said, it does not cover all the rules, but 4 big rules that really are important.